Today we're talking about why creatures like the octopus are more well suited to star in the show Blue Bloods than Tom Selleck. I mean, besides their incredible acting credits, the octopuses have got the range, y'all.
5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 33 minutes past the hour. Liftoff on Apollo 11.
Hey everyone, welcome back to the STEMulus. I'm Steph, and today we're doing another episode of Weird Science. With science fiction weaving its way into pop culture, we've been introduced to a lot of different alien races that have blood that's not red, including Spock and the rest of the Vulcans who bleed green, while the Kree from the Marvel Universe bleed blue. While the non-red blood definitely adds to the sci-fi elements, there are plenty of creatures from Earth that also don't have red blood. But before we jump into those weirdos, let's talk about what makes our and most other vertebrates' blood red. In our blood, there are three types of cells: white blood cells or leukocytes, platelets, and the aptly named red blood cells. White blood cells help us fend off stuff that makes us sick, such as viruses or harmful bacteria. Platelets are what allows our blood to clot, and lastly, the red blood cells are the oxygen carriers that also carry carbon dioxide to our lungs where we exhale the gas. So what makes red blood cells special and able to do these two tasks? Well, a little something called hemoglobin. Hemoglobin binds to the oxygen and carbon dioxide in our blood, allowing the red blood cells to carry both gases to where they need to go in our bodies. Hemoglobin is partly made up of iron, which is what gives our red blood cells their red coloring, and since these cells far outnumber the white blood cells and platelets, our blood comes out, well, looking red. So what animals out there don't have red blood? Well, there's the skinks of New Guinea for starters. These lizards share the same color of blood as Vulcans, a lime green color, which actually makes their tongues, muscles, and bones look green. They too have hemoglobin, but what makes their blood turn green is the presence of something called biliverdin. Biliverdin is a waste product that comes from when the red blood cells break down. We actually produce this chemical as well, but most vertebrates have the ability to filter it out of their bloodstream since it can harm their cells, neurons, and DNA. However, this isn't a problem for the lizards at all, which is a good thing since the concentration of biliverdin in their blood is high enough to kill a human before we would even have time to worry about our blood being green. Tube worms also have green blood, but their green blood comes from something very different, a protein known as chlorocruorin, which appears green when concentrated. Jumping to the other side of the sci-fi spectrum, one of my favorite animals on Earth shares the same color blood as my favorite superhero, Captain Marvel. So who is this other blue-blooded renegade? Well, it's everyone's favorite 8-tentacled mastermind, the octopus. Rather than using hemoglobin like most other vertebrates do, the octopus, along with many other invertebrates, use a different protein called hemocyanin. While both of these proteins are capable of binding and transporting oxygen throughout the body, hemocyanin incorporates copper rather than iron, which causes the blood to turn blue rather than bright red when it becomes oxygenated. This helps the octopus out in particular, since the deep sea environment it lives in tends to be oxygen poor, and hemocyanin is better at carrying the oxygen than hemoglobin, which is crucial when the oxygen is such a critical resource. The hemocyanin also helps regulate the salt content of the octopus's blood, such that it matches the salinity of the water they happen to be in. However, the hemocyanin does make it so that the octopuses struggle to adapt to any fluctuation in the acidity of the water they're swimming in, which can ultimately kill them. There are lots of other animals that have blue blood as well, including crustaceans, spiders, scorpions, horseshoe crabs, and even some types of mollusks. So what about animals that have it somewhere in between blue and red blood? Well, brachiopods and peanut worms both fall in that spectrum with their purplish blood. The purplish color comes from the fact that these guys don't rely on hemoglobin or hemocyanin, but rather hemerythrin, a protein that, you guessed it, is purple in color. It contains iron atoms like our friend hemoglobin, but they're arranged differently, which actually causes deoxygenated blood to look a little yellow, and once it becomes oxygenated, it becomes a purplish pinkish color. There are even some creatures that have yellow blood all the time. Sea cucumbers have a high concentration of vanabins in their blood, which turns it yellow. Scientists aren't actually sure why the vanabins are in the sea cucumber blood since they don't play a part in carrying oxygen. Sea cucumbers actually use hemocyanin for that task. They suspect that the vanabins may be a defense mechanism that makes the sea cucumbers unappealing as a snack for their natural predators. Another creature that doesn't have red blood, or any hemoglobin at all for that matter, is the crocodile icefish, which, yes, is absolutely the stuff of nightmares. These guys hang out in the ocean near Antarctica, so needless to say, they're surviving some pretty extreme conditions. The water there can get down to 28.5 degrees Fahrenheit or negative 1.9 degrees Celsius, which all of you out there that have taken chemistry will know is below the freezing point of fresh water. Since it's so bleeping cold, it's actually a huge advantage to not be carrying around a lot of red blood cells since they'd have a hard time circulating in these temperatures. So the crocodile ice fish have evolved to not have any red blood cells at all, instead using the ocean to help it circulate the oxygen throughout its body. Since cold water actually has more usable oxygen than warmer waters, the crocodile ice fish just goes ahead and absorbs the oxygen directly into its bloodstream. And by the way, its bloodstream is actually colorless, setting it way apart from any of the other species we've talked about today. So that brings us to our question of the day. What is your favorite non-red-blooded species, real or fictional? Let me know in the comments section down below. If you want to learn more about what I talked about today, I will include links to all of my sources in the description down below, along with links to all of my social media and my Patreon page, so feel free to check those out. If you're new here and you find my terrible jokes and geekery tolerable, hit that subscribe button and turn on notifications so you never miss out on any of my future videos. I'm always looking for new weird science topics to cover, so if you've got any that you want to know more about, send them to me on any of my social media pages using the hashtag WeirdScience, and I just might make it into an episode. Also, this is the last week of my Steph 30 giveaways. To celebrate me hitting the big 3-0, well, tomorrow, I'm doing a giveaway each week. All you have to do to enter is 1, be following me on Twitter at @STEMulus, and 2, retweet the video link sometime throughout that week. I always pin the video tweet at the top of the feed too, so if you go to the STEMulus Twitter page, you can find it there. Since I missed last week thanks to a sinus infection on Sunday, I will be randomly selecting 2 of the people that retweeted the link to win a prize. This week, the first prize will be one of these t-shirts like the one I'm wearing here, and the second prize will be the winner's choice of an item off of my merch site. I've got the link in the description down below, so if you want to go scout some gear or even pick up some on your own, go ahead and check it out, and if you want a shot at getting either of these items, keep an eye out for the link on Twitter and you could have a chance to win. But with that, I hope you all have a wonderful rest of your week. Stay well, stay awesome, and I will see you in my 30s. Woo!